This is week 3. We're still in understanding energy, the heat system design, and we're recapping some of the main concepts. We're trying to talk about heat as energy. We know the difference now between energy and power. We talked about energy transport, how energy goes from hot to cold, and how we transport this heat from one place to another. And along the way, sometimes we have some losses. And we talked about the first law of thermodynamics, which is what, Marcus?
Conservation of energy.
Conservation of energy. Energy does not get destroyed or come from nothing. And one is the second law, Hunter.
Something about putting using air from the outside to inside or something like that.
Something similar. Help, Mike.
Heat moves from the hot to cold,
And
and
if you want to do the opposite,
you gotta put the same
amount of energy. There's two parts. Heat goes from hot to cold, and if you want to go from cold to hot, you have to put the same amount of energy. Question?
How did heat transport or how did transport heat?
Say again?
Is it how to transport heat or how to?
No, how to transport heat. We made heat in the boiler, and you want to move that heat to the living room. And we talked about the concept of billiard balls having energy, and when they hit each other, the energy goes from one molecule to another. And I'm trying to make the idea that when you heat something, you give it more energy and more dynamic in a molecular level. And this is how we move energy from one place to another. We talked about also, if you have a boiler, probably you have water in your system, and you have these baseboard heaters that they make heat, and in the middle, as you can see, there is a tube, and this tube has what in it? Water. So we're using water as a fluid to move heat from the basement to your living space. What if you have a vent? What are you using?
forced air.
Huh?
Forced.
Air, using air. Which is more efficient, do you think, to absorb more heat and transport the heat? Air or water? What do you think? Water.
Takes longer to get water out.
Water has more energy, right?
Yeah.
That's why your car has a radiator with water in it. Does cars have, what car has an air radiator? VWs, the old ones. the new ones. What about your motorcycle? Does it have a fluid radiator or air radiator?
Air.
It's a small bike.
Well, there's a few that they have
Yeah.
that are big ones too, so.
That motorcycle has 12 cylinders. The small ones, they have usually, the air is enough to dissipate the heat. So we're using air. Air is faster to move, but does not absorb as much heat because it's gas. Fluid, liquid as fluid, absorb more heat and transport more heat, and also hold more heat. Your coffee takes at least 15 minutes to cool off. It holds heat for a long time, depending on how hot is the room. So it holds heat, and it takes a lot of energy to heat it. So we'll talk about the 3 means to transport heat. These are the heat transfer laws. Convection, conduction, and radiation. I'm going to erase this. Everybody's done with this?
Yes.
And heat transfer mode. I'm spending a lot of time in these concepts because they're very important. They will carry on later on, and you'll see the relationship between them. Jason, pay attention. Convection is something that happens in fluids. What is fluid? Give me an example of fluid. Water, air. Air is fluid, right? So fluid, something that moves, that's convection. Convection happens when you have molecules moving freely. Molecules of air move faster than the molecules of water. And so we use convection to transfer heat through water. So whenever you have, it's liquids and gas, fluids, liquids and gas. Make sense? Convection has to be through fluids. Fluids are liquids and gas. And there are two types of convection. So we all know that hot air rises and cold air drops. Why is that?
Because cold air is heavier than
Heavier. Same thing with water. So what happens if I have a heater here by itself, a hot plate? If I have a thermal camera, actually I have a thermal camera, I'll show you. You'll see the air rising, cooling off, and coming down. And this will produce a movement inside the room. So eventually it will heat the entire room at some point, but it's gonna be very slow. That is called free convection. Hot air or water rises. Cold air or water drops. That's free. By itself, eventually it will heat up. When you put your pot of water on the stove and you heat it from the bottom, it will start to circulate just by that fact. And the same thing happened with the room. When I use this baseboard and it heats the room, is this free or forced convection? No, it's free because it goes by itself. I haven't took off. The hot air will go by itself, it comes back, and you don't do anything. So which brings me to forced convection.
Oh, so that's like forced hot air.
Yeah, there's a
Or
fan,
like
there's an
like
inducer.
An AC.
This is forced. This is forced. It's not natural.
Your oven.
Natural, using buoyancy, low energy. Forced, use a fan, use a pump water, that's forced. What's another example? So forced convection. So I'm gonna test you now. The water, the heat transfer from the boiler to this pipe, is it forced or free convection?
The water that's forced to it is forced.
Forced, there's a pump,
Yeah.
pumping water from the boiler all the way to the pipe. What about the heat from the baseboard to the room? Forced or free? It's free. So free, there is no fan, no pump. Forced, there is fan or a pump. Good? And that's convection for you. Convection has fluid. Convection can be forced, can be free. That is convection. It's the most elaborate one. Conduction is easy. What is conduction?
It's direct contact with the heat
Through
source.
solid.
Yeah.
Heat transfer through solids. If it's through a solid, it's conduction. If you heat a piece of plate and it happens on the other side, that's conduction. So conduction through solids, convection is through fluids, and the last part is radiation. That's radiation require a medium,
A medium?
substance or material?
Yes. Yeah.
You think so?
No.
Is there anything between us and the sun?
No.
The
It's
ozone.
vacuum, it's empty. So radiation goes through vacuum, through nothingness. It's waves. So the sun radiates to the earth. It takes 8 minutes for the sun rays to come here, travel through vacuum. And radiation having the same mean. You do not need any kind of medium. There's
So
no
it's basically heat through waves.
heat through waves, exactly. Infrared heat. So radiation. The medium heat through waves. I'm using verbiage. Heat through waves. Do we have that in HVAC? Yes. You go to a bar and around actually this time of year, and they have those usually radiators, like troughs, with hot rod in the middle and just like radiating heat to you.
No.
And you have, yeah, guys. And they have at home you can buy a small space heater that has a small, look like a dish, and it radiates basically completely through infrared. Where else do you see these?
They have it on top,
Where?
the post office.
Yeah. Where else do you see like infrared heaters?
At the entrance of a building?
Yeah.
Shops, restaurants.
Yeah.
Restaurants.
Yeah. Restaurants.
Like if you're waiting outside.
Fast food.
the line is
Actually
long.
for fast food, if you go, usually they put the food under the heat lamp.
Oh, yeah, they do.
yeah.
Because if they use convection, what's gonna happen to the food?
We're gonna know.
Yes, you know, it will dry out. If you leave it for 10 minutes there, it's gonna dry out. It's not gonna,
Oh,
that's
yeah,
good.
okay.
So they put infrared lamp, so it will heat the food and in a way that's not going to
So
dry it
would
out.
a microwave be forced convection or would that be radiation?
That's different. That's radiation.
Yeah.
And different microwave, heat solids. It does the same thing. So I will show you what it looks like.
Doesn't microwave just excite the water molecules and that's what heats up?
What does it do?
Excites all the water molecules.
All the molecules. And it actually heats solids more than
That's why it dries out in the microwave.
That's why if you put a spoon there, it will spark and melt. You can melt the spoon in the microwave for 3
You can
minutes.
also kill yourself.
So the radiant floor heating is not so much as a radiant, but it has it forces water into the pipe in the floor,
Yeah.
but then it frees.
No,
No,
you're right.
then it
actually-
radiates.
No, yeah, you're right. Actually, you got it. It's a good point. The radiant floor heating in a house is actually completely radiation. It radiates to the house. Not even convection, not conduction, nothing.
Well, it's going through your hardwood floors.
Yeah, but it's not heating through convection or conduction. You heat the floor, and the floor radiate to the room. And if you notice, radiant floor heating is one of the best ways to heat a house because it does not have to be too hot. 85 is enough. And 85, because we're using the floor, it's big surface area, it will radiate to the.
And it would be radiated because you're basically just talking about the heat transfer.
Yeah.
Not how it's.
Yeah.
Oh,
It's not
instead of
heating the
having-
air, it's heating you.
And if it's in a concrete floor, it stays hot for a couple of days.
Yeah, it does.
You're-
But again, yeah.
You meant like when you said it doesn't, 85 is enough, you mean maybe 85 temperature
Yeah.
in the floor instead of like 125
Exactly.
for a furnace
Exactly.
or whatever?
So it will save you a lot of energy because you don't have to go 185 in the radiator. 85 is really enough. And you can use solar for that, you can use flowing, you can use like shale, you use like small source of heat. 85 will radiate the entire floor. And also they have radiator panels. You can radiate you can heat the walls and it will do radiation to the room. But the caveat of radiation in house, you need a big surface area. That's why I use the floor. Yeah.
I was gonna say, I actually have a house that where it's a radiant floor, but they're using a waste oil burner to heat the floor
Yeah.
in a garage.
Yeah, you could do that. Okay, so that's the radiation. So this is to recap: conduction, heat transfer through direct contact with material, solid. Convection, heat transfer through fluid movement, natural. It's buoyancy driven, which means like buoyancy is something floats and something sinks. Forced, moved by a fan, pumps, etc., mechanically forced. And radiation, infrared electromagnetic waves produced by heat. Regular light And animal lights, I mean, if you have a fish tank, you always have an infrared lights to heat. If you have a reptile tank or something like that, you will need an infrared lamps. So those lamps actually just produce infrared lights and not regular light. LED, they don't have a lot of the infrared or the ultraviolet. They only have the visible light. I'll show you the waves here. So this is, of course, everything is transparent into the universe is a wavelength. All waves are sinusoidal wave, which means like they can be transferred into like a sine wave. What's a sine wave? Okay, let's not say that.
Trigonometric.
Anyway, it's this wave. It goes back and forth. It's a wave. And this, what is the frequency? It's how many cycles when it goes up and down to a bottom again. So this is a complete cycle from here to here. And how many of those in 1 second? So you can see these are the wavelengths. So when you talk, I'm vibrating, sending you a wave. The wave is touching your eardrums and you hear me. That's a wave. Light is a wave, depending on the frequency. Your ear will pick up some frequencies, but not others. And so on and so forth. You're gonna go to different kind of frequencies. These are like really high frequencies. And if you look here, this is gigahertz, which means how much hertz. So mega is a
10,000?
kilo is 1,000, mega is a million. This is 1,000 million.
So a billion.
Yeah, a billion. This is a billion hertz.
Oh, okay.
So this is the frequency: gigahertz, megahertz, hertz, 3 hertz wavelength. Low frequencies, and again these are kilohertz. 3 hertz is very small. It's a wavelength here. If you go higher, sending frequency, these are cell phones, TVs, microwave, satellite. Same thing. You might have different kind of microwave in your oven that can heat stuff. And here what we have as light, and that's around 330 picohertz. This is terahertz. Tera is a million.
Wow.
This is pico. I don't know how much is that.
It's like
That's
10
a
to
lot.
the 12th, I think.
Something like that.
Yeah.
Anyways, this is the frequency that produces light. So when the atoms vibrates this much in a second, you're gonna have this wavelength. So this is the visible light that you see. Below that, you have from here to here you have infrared and heat. Over this you have more waves that could cause cancer. Ultraviolet. It's too fast and too penetrating that it can change your body structure and your DNA. This is the visible light, and it's all come from the sun. Above that, you have X-ray, which can go through your flesh, and you can see bones, because bones are solid. And over that, you have nuclear, radioactive waves. It vibrates so much that even without heating, it glows.
Oh.
So,
It says on the bottom there what it is. So 10 to the 15th.
yeah. I can't even read that. So, tera, I know giga and tera, I don't want to know this. Petahertz, okay, petahertz. So, this is waves. So, what I'm trying to say to you is the infrared here is a wave, and it comes with light, and we can use that to heat. And this is radiation. The sun is sending us all these waves, and they are, some of them are visible, some of them are just heat. So when we look at windows, and window selections and panels, we look at what we want. What do we want from a window? We want the visible light, but we're getting the whole bundle. So we're gonna try to find ways to block the ultraviolet and block the infrared and allow the visible. And this has been a challenge for a long time, but it's possible. So we will look for that. If you look at your car windows, probably they say UV protected. There's UV protection. UV is just the cancer-causing waves. The infrared is what causes you the heat. So you can get a tint that's completely clear, that only blocks the infrared, and the car will still be cool.
What do they make out of the radiation suits that blocks radiation out? Is it lead line?
Say what again?
You know how people wear radiation suits, whatever
Yeah.
they wear? Is it lead lined, or how does it block out radiation?
There's a lot of things. What is the easiest way to block radiation? Those who treat the cars. What is the best way to block radiation?
on your car?
In anything.
I thought it was lead.
Covered like
Lead. Mirror.
Reflected back.
Yeah, reflected back, nothing can go through.
No.
If you have completely reflective surface, everything will go. That's why in a thermos, in a good thermos, if you look inside, it's very shiny. It's to reflect back. Space suits, they have reflective side. If you buy a good jacket, if you look at the lining, it's very shiny to reflect the radiation coming from your body to the jacket. So shiny stuff are very reflective because they reflect the light, nothing is going through.
Is that why they have in space they have those big wings that are incredibly reflective that use the sun to push them?
That's a different thing.
No.
Solar
yeah.
sails?
Yeah,
Solar
solar
sails,
sails.
yeah.
Thank you.
There's like when you go camping and stuff, like those blankets, like where you get heat. It
Oh,
has,
the
like,
woman.
Yeah,
blankets,
yeah.
Yeah.
So reflection also because your body now, I am now conducting and have convection and have radiation. The air around my body, if you look at the thermal camera, is very hot. I'm doing natural convection to the room. I'm conducting through my feet to the ground. I'm also radiating heat. So your body, everything has the three modes of radiation happening at the same time. However, so we try to fight those things. If we want to buy a really, really good jacket, it's gonna, first of all, it's gonna fight convection. How does it do that? They stop the air from moving. You have rubber bands in the arms, it zips up around your waist, so it's keeping the air inside, there's no convection. Okay, conduction, they have insulation inside, that's the filling, they put good filling in it. And also you're gonna have some reflective surface. So whatever radiation you have from your body is going to be reflected back into you. If you buy a ski jacket, probably it's very expensive because of these materials and selection. Question?
What do they call, I've seen it in some places of the country that I've been, just big black tanks up on top of roofs that heat off all their water. And
Yeah.
They're just black, they're just
Yeah.
tanks that are black.
It's a good way to heat the water for free. To get warm water so it doesn't cool off. It's just that the color will keep the
Winter and summer,
Huh?
winter and summer.
Yeah. It's even the summer's not gonna get too hot. They want it to be hot, and also probably they want the water to be hot so it will kill some bacteria. There are some designs for that. And speaking of that, I had a thought, forgot about it. But yeah, it's the same thing. So the color has a big thing to do with that. Reflective surface, so you want something to reflect. But again, if you have a complete mirror and you reflect everything, you don't get the visible light. That's why if you have a car tent that's completely reflective, it's really hard to see through it.
Mhm.
So that's a caveat of the whole thing. So now they have specialized film that will block infrared or block only ultraviolet. Okay. So going back to the sun, how hot is the sun? Around 10,000 degrees Fahrenheit, even more. 49 of the sun energy comes to Earth as heat, and the 64 comes as visible light, and 5% is as UV radiation. So if you think about it, the visible light, the solar heat is 46 is only the visible light. That's what we're using for photovoltaic panels. What about the 49, the heat? We're not using that for energy generation that much. Unless you use a tank like that or something that stores heat. So that's again another way to harvest energy. The ozone layer that we put a hole in, it blocks the UV naturally. Why? Because UV is very cancer causing and can change your DNA. And there are some theories says that the Earth spinning causing some kind of magnetic shield to the Earth, so it blocks a lot of ultraviolet. Otherwise, at some point it does slow down. It will slow down, a lot of electromagnetic waves come to Earth, and it changes DNA and creatures, and that's how evolution happens. But again, it's just theories. The sun gets closer and further. We know that because of the seasons. And what does that mean? You're gonna have seasons back and forth, so we gotta have to accommodate for that. Reflection and absorption, that has to do with color and how this affects us in heating and cooling. So you can cool a house and heat a house based on the color change. And if you also notice that animals do that too. They have like dark colors and winter coat and summer coat depending on what is needed. And of course for living creatures that's a different story. Dark skin does not allow as much UV to the body, because UV again is cancer causing, cancerous, so that's why it blocks more. That's why you wanna go outside in the summertime without sunblock. You need that. And if you look at new apps now, they can monitor the UV index. They tell this is high UV day, low UV day.
Yeah.
So you,
I'll watch this.
yeah, a lot of, it's important. Color, what I want to say is, heating a pool in places like in the south of Florida, they actually do have floors that are darker, so you can heat the pool for free using the sun. Just by the,
In the pool?
yeah, you can have darker color in the bottom that will do that. Or sometimes they use also a cover on the pool, a dark cover, you spray in the water, it will absorb the heat and heat the water over time.
I've also seen these, they're almost like roll panels that have water going through them, and that's how they pump the water from the pool through the black
Yeah,
panels
yeah,
back in.
yeah, it is possible. And they also have color changing tiles. When it's very sunny, it will get darker and absorb the sun. And they have also activated colors, so you can plug it in to turn dark, then you can plug it out to cool off. It's there's a lot of technologies out there. Okay, the last but not least for this section is human comfort. So as I said before, human are tropical creatures. So this is tropical weather we're looking for. So our comfort is between 65 and 85 degrees. Between those two lies the human comfort. There are some extreme cases where people like 60 or 90, but most likely human beings like to be between 65 and 85. That's a good weather. Now we want to be at thermal equilibrium, meaning we're gonna lose heat or gain heat depending on our atmosphere. Also, it depends on your body metabolism. So when you sleep, your metabolism goes down, right? That's why you wanna make sure that the room is warm enough for you to sleep. However, if it's too warm, you can't sleep. You need, it goes vice versa. If the room is cool, it will lower your metabolism and you'll feel sleepy. And when you sleep, it will drop even more. So make sure there's a blanket. That's why they tell you sometimes do not sleep unless you're really covered, because when you sleep, and you might drop your metabolism even more, and you might not wake up. You're going to like hypothermia. For people who hike, probably know that very well. If you hike, you go into the mountains, you always tell you to get a good sleeping bag, make sure it's the right temperature, because again, temperature will drop at night, and your body temperature will drop as well. If you don't wake up, probably your body will go into hypothermia, and which means like shut down to preserve as much as possible, and you might not wake up. So make sure it's very, very warm. Airflow does affect us. That's the draft. So that's why sometimes the fan can help out into cooling or heating the space. So sometimes the fan just pushing the air that's stuck to your body is very helpful. Even though it's safe, your body is really hot, but your body is up to 85. Surface body is 85. What is the body temperature inside?
96.
Yeah? And how much calories do you consume just doing nothing? Around 2 calories a minute, and your body keep burning energy. So you need something to cool off. And we'll talk about sensible latent heat. Your body can dispense heat out of your skin, spare skin, up to 80. Until 80, your body can you don't have to sweat. Just by wearing shorts and short sleeve shirts, you can just dispense heat. After 80, what happens? Your body starts to get warm. You'll sweat, hoping that the sweat will evaporate and will cool the body. If it doesn't evaporate, you'll keep getting hot. If your body temperature reaches over 100, what happens?
Fever.
Fever, then what?
Dehydration.
Yeah, and you'll shut down.
Yeah.
The body will shut down because to try to lower the metabolism of what you're doing. So there's a lot of heat stroke going on. This is the heat stroke when your body shut down. What happens if you keep heating and cooling yourself off after 100, 110? And that's why fevers are very, very dangerous for kids and elderly. What happens?
It will fry your body.
You actually start cooking your brain.
Yeah.
It doesn't take much. So that's why people with kids have fever, they sometimes lose senses, or they have issues. The same thing with adults, but we can retaliate more, but when you're older, your body cannot like balance itself. So heat is very dangerous, so is cold. So being in the right temperature is very important. It's a health aspect as well. Airflow and radiant heat. Again, there are so talking about radiant floor heating. Why do people prefer radiant floor heating, even though it's very, very expensive?
Comfortable, you can't step on it.
That's one thing. What else?
Doesn't it dry your body?
Yes.
It's better for the air.
Yes. Does not move the air. So you don't even know it's there. No draft, no forced air, not very hot, comfortable to step on, and it actually achieves the right amount of heat and the right profile. What does that mean? You want your feet to be warm and your head to be cool. So where's the heater? In the floor, where you want your feet to be cold, hot, and your head to be cool. So it has the right temperature profile. It's very comfortable, it's very nice. However, it's very elaborate to install and costs a lot of money. But it is the best thing for human comfort. What is degree day temperature? That is something you're gonna use for the project. Once I give you the project, degree day.
day?
Yeah,
Degree day?
yeah, or design day temperature. D. You'll see that, which is, what is it? So this is the design temperature, where I'm going to do my calculation based on. So in the winter time, what day I'm gonna design on for? You're gonna design for the coldest day of the year, right? Zero. In Springfield, zero. It's the coldest day in the last 10 years, zero. So you're gonna design for that day. So when that day comes, your system can handle the heat. In the summer, it's gonna be the hottest day of the year. So that's the degree day. Make sense?
I thought we went below this.
Yeah.
Basically, you
It
design
goes for a few hours.
the coldest
Cause I know there was one
day in the winter,
that was
and the hottest day in the
Huh?
summer.
They got that baseline temperature?
Yeah.
Sometimes it's lower.
Yeah. So you can always look it up because update the last 10 years, actually, or 4 years that we have many countries. Okay. We'll stop here.